Hi, grade 7. How are you? I hope you are all well. Today, inshallah, we are talking about momentum. So we will start our video with a small video on momentum to facilitate the momentum. Momentum is so easy, by the way. It's a very easy topic. I will start by a small video, so let's show the video, please.
Physics Essentials video 49, it's on momentum, which is just the product of the mass of an object times its velocity. In 1895, a train was headed towards Paris. They were a little bit behind schedule, didn't apply the brakes in time, and it came shooting out through the train station. What was their problem? They had too much momentum. And if you were to ask somebody what is momentum, they'll probably come up with a pretty good definition that would fit in physics. Momentum is always going to occur if we have a...
So please, grade 7. As you see here, the train is going through the train station. The train goes through train station. Do you think why? Why the train goes through the train station? Yes, before the train has so much momentum. What is the momentum? Momentum, this is a physical property of a moving object. Any moving object has mass and velocity. The multiplication of mass and velocity produce something called momentum. So momentum, this is a physical property that is produced from the multiplication of the mass and velocity. So let's think together. If a car and train both are moving with the same velocity, for an example 60 meters per hour, let's say an example, do you think which have more momentum? Yes, right, train. Why? Because the mass of the train is so much bigger than the mass of the car. So the total result or the net result, that the momentum of the train is so much more than the momentum of the train, the momentum of the car. Okay, so momentum, this is a physical property of the moving object produced from the multiplication of mass and velocity. Okay?
Momentum, they'll probably come up with a pretty good definition that would fit in physics. Momentum is always going to occur if we have an object that's in motion. And if you want to calculate it, you simply multiply the mass of the object times the velocity of the object. The greater the mass, the greater the velocity, the greater the momentum is going to be. And so if we want to change our momentum, what could we do? Well, we could decrease the mass, we could increase the mass, or we could change the velocity. What's the easiest way to change the velocity is to apply a net force to that object. If we apply a net force to the right to this object, what are we going to see?
So grade 7, momentum, this is the multiplication of mass times velocity. Mass times velocity. So let's see. Let's see here. Okay. This is the momentum. Momentum is, this is the equation, mass times velocity. If you write it by abbreviation, momentum take letter P, mass take letter M, velocity take letter V. So if you write it by the abbreviation, P equal M times V. P equal M times V. This is the equation of momentum. Okay, so I will give you an example. Okay, here please. Calculate the momentum of 6 kilogram bowling ball moving at 10 meters per second down toward the pins. Yes. How to calculate the momentum of this bowling ball? How to calculate the momentum of this bowling ball? As I told you before, first we must get out the given. What is the given here? The mass 6 kilogram, the velocity 10 meters per second, mass 6 kilogram, velocity 10 meters per second. So calculate the momentum. How to calculate the momentum? Yes, right. Momentum equal mass times velocity. mass times velocity. This is the momentum, mass times velocity. If you write it by abbreviation, so momentum for P, mass for M, and velocity for V. So this is the first step. This is the first step. This is for 1 mark. Then we will make what? Yes, substitution by units, please. Yes, mass is 6 kilogram and velocity is 10 meter per second. So momentum equal 60 kilogram meter per second down the alley. Okay, so this is the unit. This is the unit. What is the unit of the momentum? Kilogram kg meter per second. The unit of mass and the unit of velocity, kg meter per second. Okay, so this is the unit of momentum. So again, please, how to solve a problem of momentum? First, write the equation: momentum equal mass times velocity, P equal time M times V. Then we make substitution. This is the first step. This is the second step, M times V. M equal 6 kilogram and velocity 10 meter per second. This is the second step for the second mark. The third mark, as I told you before, if you can get out the number, if you have calculator, okay. If you don't have calculator, it's not problem. My problem is in unit. You must know the unit by heart, kg meter per second. Let's show you another example, please. Yes, let's show you another example here. Okay. Which has a more momentum, a 3 kg sledgehammer swung at 15 meter per second or a 4 kg sledgehammer swung at 0.9 meter per second? How to calculate this, how to solve this problem? Okay, first we must know the momentum of each one of them. Okay, so the first sledgehammer, mass is 3 kg and velocity is 1.5 meter per second. The second sledgehammer 4 kg and velocity 0.9 meter per second. Let's solve. Okay, first momentum equal P equal M times V. Yes, mass times velocity. Yes, so it is 3 kg times 1.5 meter per second square. Then the second is 4 kg times 0.9 meter per second square. Meter per second. Yes, let's solve. Yes, right. Yes, here momentum, mass times velocity, or P equal M times V. So how to solve? Okay, yes, 3 kg hammer has more momentum than 4 kg. You solve it. Yes, right. We will solve together. Yes, 3 1.5. Yes, it will be equal. Let's solve together. Please solve it by yourself. Let's solve together. Yes, 4 0.9. Yes, so I solved it. I already finished. Okay, so the first one, that the sledgehammer 3 kg times 1.5 meter per second, so it is 4.5 kg meter per second. Okay, so this is the first one, the first sledgehammer, momentum is 4.5 kg meter per second. The second sledgehammer is 4 kg, this is the mass, and the velocity 0.9. Okay, so it is 3.6 kg meter per second. So the first one, the smaller sledgehammer, why it is smaller? Because it has small mass, okay, has more momentum than the large sledgehammer. Okay, so this one have more momentum than this one. Yes, right. Okay, so the 3 kg hammer has more momentum than the 4 kg hammer. Okay, yes. Okay, so from this equation, what did you get? You got that as mass increase, momentum increase, as velocity increase, momentum increase. So mass is directly proportional to the momentum, velocity is directly proportional to the momentum. As mass increase, momentum increase. As velocity increase, momentum increase. Okay, is it easy? So again, please, what is the momentum? This is a physical property of a moving object produced from multiplication of mass and velocity. So if you write the equation that P equal m times v, m for mass and v for velocity, m unit is kg, kilogram, and velocity unit is meter per second. So if I ask you what is the unit of momentum, yes, what is the unit of momentum? Yes, right, it is kg meter per second. It's so easy. I think it's so easy. So if I want to increase momentum, what can I do? If I want to increase momentum, what can I do? Yes, increase mass, increase velocity. Yes, both are right, because they are both directly proportional to the momentum. So if mass increase, the momentum increase. If the velocity increase, the momentum increase. But mass usually is fixed. Mass of the car is fixed. Okay, so what I can increase it is the velocity. How can I increase the velocity? How can I increase the velocity? Yes, by applying more force. So if I increase the force, I give it to the car, its velocity will increase, and so its momentum will increase. Let's see this in the video, please. Yes. Okay, some problem in the video. Okay. Okay, some problem happened with the video. Okay, so if I increase the net force applied to the, by the way, this video will be uploaded to the site, inshallah. So if I increase the net force applied to the car, for an example, the net force increase, so the velocity increase, so the momentum increase. So again, please, grade 7, if I apply more force to the object, this object will have higher velocity and so will have higher momentum, because momentum is a multiplication of mass times velocity. So if I increase the net force applied to the object, its velocity will increase, and so on, its momentum will increase. I think it's so easy. Momentum is so easy. We still have a small point in the momentum, which is the law of conservation of momentum, but I will postpone it to the next video, inshallah. Okay. I want you to solve this, please. A golf ball travels at 6 meters per second, while a baseball moves at 7 meters per second. The mass of the golf ball is 0.045 kg, and the mass of the baseball is 0.14 kg, which has a greater momentum. Please solve it. I will solve it with you, so we'll take 2 or 3 2 minutes to solve. I think it's enough. Okay, this is the golf ball. Okay, and this is the baseball. Okay, please concentrate, please. This is the golf ball and this is the baseball. The golf ball mass, the mass of the golf ball, 0.045, and the velocity travels, this is the velocity, and the velocity of the golf ball is 6 meters per second. Please write with unit to avoid forgetting of unit. Please write with unit, solve with unit. So, okay. Okay, I get out the momentum of the golf ball. Who get it? I get out the momentum of the golf ball. Who get it, the momentum of the golf ball? Okay, now I will make the baseball. The baseball is 0.14 kg. This is the mass. What about the velocity of the baseball? 7 meters per second. Again, I remember, please put with unit to avoid the forgetting of unit. Okay. Okay, so I get the momentum of both the baseball and the golf ball. The golf ball momentum is, yes, who make it like me, 0.72 kg meter per second, and the baseball is 0.98 kg meter per second. So which had the greater momentum? Right, the baseball had the greater momentum. Okay, so I think it is so easy. I think it is so easy. Yes, let's solve another example. I think by this example the momentum will be so easy. What is the momentum of the bird with a mass 0.018 kg flying at 15 meter per second? Yes, I think it is right. Yes, let's solve together. Yes, step by step. P equal, which is the momentum? P equal, yes, right, M times V, mass times velocity. What is the mass here? 0.018 kg. Yes, right. What is the velocity here? Yes, 15 meter per second. Yes, right. So can you calculate it for me, please? 0.018 times 15. So it is 0.27 kg meter per second. Yes, it is so easy. I think it is so easy. So this is the momentum. This is the momentum of the bird flying. Okay, so this is the momentum. I think the momentum is so easy. You can get it so easy, I think. So okay, let's solve directed reading A together. By the way, directed reading B, yes, directed reading B is a homework. This section of the momentum is homework. Yes, the first page, page 19, this is homework. Okay, this is homework. The one who have his assessment book will get it. If you don't have the assessment book, I will upload the directed reading A and the directed reading B and the assessment sheet on the site. Okay, so if you don't have your assessment book, you will have it on site, inshallah. Okay, so this page, please, 19 only. 19 only is homework. Please solve it and return it back to me on mail or on Google Class. Okay, let's solve directed reading A together. Okay, first question, please. Why does it take a large truck longer to stop than a compact car, even though both are traveling at the same velocity? This is the same example as I give you, but I give you an example with train and car. Okay, so this is, I think, the same. Okay, this is a large truck and this is a car. Okay, both are moving with the same velocity. For an example, velocity 60 meter per second. Okay, why it take a large truck longer to stop than a compact car? Why do you think why? Yes, because the large truck has a large momentum than the compact car. Yes, right. Okay, why? Because the large truck has more mass than the compact car. Why? Because momentum equal mass times velocity. So if the mass increase, the momentum increase. So the truck takes a longer time to stop than the compact car. So if we solve this problem, we will say that because the large truck has a large momentum than the compact car, and so the large truck take a longer time to stop than the compact car. Okay, I think it's so easy. Also, the answers will be uploaded to the site. Okay, the product of the mass and velocity of an object is its mass times velocity is momentum. Right, mass times velocity is momentum. Number 3, why does a fast moving car have more momentum than a slow moving car? I think it is so easy, because momentum is the product of mass times velocity. So the fast moving car has more velocity than the slow moving car, so the momentum of the fast moving car is more than the slow moving car. Okay, so again, please repeat the answer. The momentum of car, the momentum equal mass times velocity. So the fast moving car has more velocity than the slow moving car, so the momentum of the fast moving car is more than the slow moving car. Okay, number 4, what is the equation used to calculate momentum? I think it's so easy. We studied by heart that momentum equal mass times velocity. Mass times velocity. P equal m times v. Okay. Number 5, match the correct description with the correct term. Write the letter in the space provided. The mass of an object in kilogram. The mass, I want the symbol here, okay? I want the symbol. The mass, what is the mass? Yes, it is A. It is A, 5, A. Yes, mass is A, right? Okay. The velocity of an object in meter per second. What is the velocity of the object in meter per second? Yes, I want the velocity. What is the symbol of velocity? Yes, it is V. Right, it is V. The unit of momentum. What is the unit of momentum? To know the unit of momentum, you must know the equation. What is the equation of momentum? M times V. Right. So M, this is the mass by kg, and V, this is the velocity, meter per second. So the unit of momentum kg meter per second. Yes, it is C. Right. Okay. Sorry, this is the unit. Sorry, it is the P. Sorry, he need the symbol. So it is P. Sorry, so D. 7G. Then the kilogram multiplied by meter per second. This is C. This is the unit of momentum. Kilogram multiplied by meter per second. This is C. So again, the answer 5A, 6B, 7D, and 8C. What is the direction of momentum? This is a critical thinking. This is a question for critical thinking. What is the direction of momentum? Miss, momentum has direction? Of course. Momentum is the product of mass times velocity. I repeat again, velocity. Velocity, this is the speed in a specific direction. This is the definition of velocity. Speed in a specific direction. So, if the velocity has direction, for sure, momentum has direction. Okay? So, what is the direction of the momentum? For sure, it is the direction of the velocity. So, the momentum direction is the direction of the velocity. For an example, if a car is moving with a velocity 40 meters per second north, so the direction of the momentum is north. Okay, so what is the direction of the momentum? It is the direction of the velocity. Okay, I think this is all for momentum. I think it's so easy. Next video, inshallah, we will talk about the conservation of law of conservation of momentum. It's so easy also, but please study momentum well to go through the next step, inshallah, which is the law of momentum. Thank you so much. See you next video, inshallah.